Hello students, welcome to time classes. Topic of today's class is inequalities and modulus. Handout code is QAHO 1002112. I hope everybody has the correct handout. Now this is a continued class. We are on question number 9th, second part. It says fx equal to mod x minus 9 plus mod x minus 13. We have to find the value, find the minimum value of fx and also find the values of x, value or values of x at which fx attain its minimum value. So we draw a number line and we plot a point 9, 13. When x is less than 9, both the mods are negative. When x is greater than equal to 9 but less than 13, first is positive, second is negative. And when x is greater than equal to 13, both the mods are positive. So we will be considering these three intervals. So first, when x is less than 9, so fx, that is y, is equal to, both the mods are negative, minus x plus 9 minus x plus 13. So y is equal to minus 2x plus 22. So we get 2x plus y is equal to 22. If we convert this into intersect form, it's x upon 11 plus y upon 22 is equal to 1. We should draw this line. On x-axis, it intersected 11, 0. On y-axis, at 0, 22, it's in this manner, it moves. This is 11, 0, this point. It's declining downward. Now take when x is greater than equal to 9 and less than 13. So first mod will become positive, and second mod is negative. X and minus x cancel out, 13 minus 9 is 4. We get equation of a line which is parallel to x-axis passing through 0, 4. We have to choose in our region from 9 to 13, it's behave like a horizontal line parallel to x-axis and passes through 0, 4, because this y becomes independent of x. X and minus x cancel out. And when x is greater than equal to 13, so both the mod becomes positive. Y is equal to x minus 9 plus x minus 13. Y is equal to 2x minus 22. So it's 2x minus y is equal to 22. We convert in intersect form, x upon 11 plus x upon 11 plus y upon minus 22. X upon 11 plus y upon minus 22 is equal to 1. We should draw this line. It passes through 11, 0 and 0, minus 22. That is, this is inclined upward. And we have to draw the three lines in a single graph, the region in which it occurs. We have to choose region is, one is less than 9, other is from 9 to 13, and third is from greater than equal to 13. So this is 9, this is 13. When x is less than 9, equation is y is equal to 22 minus 2x. Between 9 to 13, equation is y is equal to 4, horizontal line. Greater than equal to 13, it's y is equal to 2x minus 22. First, it's coming this manner, then it becomes horizontal in this interval, attains a minimum value 4, then it's moving upward. value changes at the turning point. If you put x equal to 9, y coordinate is 4, x equal to 13, y is 4. So we get minimum value of fx, occurs at 9 to 13 in this interval. Any value of x you put, you get minimum value as 4 of fx as 4. The line becomes horizontal. So if you ask for how many real values of x, it gives the minimum value from all the values from 9 to 13. How many integral values? Then we can count 9, 10, 11, 12, 13. Integral values of x if it is asked. But he is generally asking for what values of x the minimum value. Minimum value is 4 and for any value of x from 9 to 13. So this is the answer. Find the values of x, get found 9 to 30, close interval, and minimum value of fx is 4. Value always occurs, changes at the end points. So in examination we can just find the values at these end points and check for the minimum value also. But ideally we should know what the graph, how the graph is being drawn. I hope this is clear. Now let's come to third part. It says mod of x minus 7 plus mod of x minus 12 minus 5 is less than 0. So we again plotted a number line and plot the turning point 7 as well as 12. So if we are taking any values of x less than 7, so both the modes are negative. X greater than equal to 7 but less than 12, first is positive, second is negative. X is greater than 12, both are positive. Now first we assume value of x is less than 7. So this becomes minus x plus 7 minus x plus 12 minus 5 less than 0. Minus x becomes minus 2x plus 7 minus 5 is 2. 2 plus 12 is 14. So we simply got the value as minus 2x plus 14 is less than 0. Or we can say 2x is greater than 14, or we can say x is greater than 7. Now we assume x is less than 7, but we are getting values of x as greater than 7. So we are not getting any value at this point. So in this, it's no solution when x is less than 7. First case doesn't give us any solution. Now let's try for x greater than equal to 7 but less than 12. So first mod becomes positive, whereas second mod becomes negative. Minus 5 is less than 7. X and minus x cancel out. Minus 7 minus 5 is minus 12. Plus 12 is less than 0. We are getting 0 is less than 0, which is not defined. So we are not getting, this is not, 0 is not less than 0. So this is also not possible. We are not getting any solution in this case also. Third case, we assume x is greater than equal to 12. So both the modes become positive. We get x minus 7 plus x minus 12 minus 5 less than 0. X plus x becomes 2x. 12 and 7, 19 and 5, 24. It becomes minus 24 less than 0. So 2x is less than 24. We take 24 to the right hand side. So x is less than 12. Again we are getting a contradiction. We are assuming greater than equal to 12 is giving less than 12. So no solution in this case also. So we are not getting any solution, any possible values of x. In all we say no solution exists for x. No solution or possible value of x. So we simply say in all the three cases we are not getting what, when we are assuming x less than 7 we are getting x greater than 7. So not satisfying. When we are taking x greater than equal to 7 but less than 12 we are getting 0 is less than 0, which is not possible. When we are taking x greater than equal to 12 we are getting values of x's which satisfy less than 12. So we are not getting any solution. So we will say no solution of x will satisfy this. Yes? Clear? Tenth question. It says solve mod x plus 7 less than 4x minus 13. Now turning point of this at which this becomes 0 is x equal to minus 7. So before minus 7 this mod is negative, greater than equal to minus 7 this is positive. So we assume two cases. Let's assume x is less than minus 7. So this becomes minus of x plus 7 less than 4x minus 13. That is minus x minus 7 less than 4x minus 13. We are assuming x less than minus 7. So this mod put minus sign outside. So x goes to the right hand side. So it becomes 4x plus x becomes 5x. 13 comes to the left hand side, minus 13 it becomes plus 13. So it becomes 6. So x is greater than 6 by 5. We had assumed x less than minus 7. We are getting x greater than 6 by 5. So we say no values of x. No values of x in this interval. We are not getting any values of x which satisfies. Then we say x is greater than equal to minus 7. X is greater than equal to minus 7. So we say this is x plus 7, mod put a plus sign outside, is less than 4x minus 30. Or we can say x plus 7 is less than 4x minus 30. So 3x is greater than 13. 13 plus 7 is 20. 3x is greater than 13 plus 7 is 20. So x is greater than 20 by 3. We assume x greater than equal to minus 7. We are getting 20 by 3 which is greater than minus 7. So we are getting values of x. So what is the solution we are getting? X can take a value 20 by 3. Now it is not equal to in this case. So 20 by 3 to infinite. We can simply say x is greater than 20 by 3. So this is our solution in this case. What is the value of x that satisfies? 20 by 3 to infinite. 20 by 3 is not counted because equal to was not there. Yes? Clear? At x equal to minus 7, this side is 0 and this side is negative, and 0 is not less than negative. You can also cross check by seeing the inequality. Where does this modulus? What are the turning point for this mod? It's minus 7, its value changes. So answer for this is 20 by 3 to infinite. Yes? Now 11th, it says ABC are the sides of a triangle. We have to find the range of a square plus b square plus c square upon 2ab plus 2bc plus 2c. Now since these are sides of the triangle, we can safely say difference of two sides is less than the third side. So a minus b is less than c. So if we can write this as a minus b whole square is less than c square, a square plus b square minus 2ab is less than c square, or a square plus b square minus c square is less than 2ab. We can write in this manner also. Similarly, we can say b minus c is less than a. So b minus c whole square is less than a square. That is b square plus c square minus twice bc is less than a square. You can say it's b square plus c square minus a square is less than twice bc. We take this first as equation 1, this as equation 2. C minus a is less than b. So c minus a whole square is less than b square. So c square plus a square minus 2ca is less than b square. So c square plus a square minus b square is less than 2ca. This is third equation we have. Which property we use? Difference of two sides of a triangle is less than the third side. And one more property we all should also know, sum of two sides is greater than the third side. Now if we add these three equations, 1 plus 2 plus 3. So left hand side we add a square plus b square minus c square less than twice ab. Then b square plus c square minus a square less than twice bc, and c square plus a square minus b square less than twice c. We just add these three parts. A square minus a square, so cancel out, only one a square left. B square minus b square, cancel out, only one b square left, plus c square is less than twice of ab plus twice of bc plus twice of c. So we can safely say that a square plus b square plus c square, and this 2ab plus 2bc plus 2c is a positive quantity and sides are positive, so we can bring this to the denominator. Twice bc plus twice ca is less than 1. We got the upper limit for this. Yes. Now this value is less than 1. We have to find the lower limit also. I hope this part is clear. We use difference of two sides is less than the third side. Now since ABC are sides, we can say arithmetic mean of two number of arithmetic mean is greater than geometric mean. We are taking numbers as a square and b square. They are real numbers. ABC are sides. So we can say a square plus b square divided by 2 is greater than equal to square root of a square b square, that is a square plus b square by 2 is greater than equal to ab. Similarly, if we apply the same result for b square and c square, we can say b square plus c square upon 2 is greater than equal to geometric mean of b square c square, which is we take square root of their product, that is b square plus c square upon 2 is greater than equal to bc. Similarly, we can say c square plus a square by 2 is greater than equal to square root of c square a square, that is c square plus a square by 2 is greater than equal to ca. Now, this is fourth equation. This one is fourth. This is fifth we have, and this is 6. So if we add 4 plus 5 plus 6, what we get? A square plus B square upon 2 is greater than or equal to AB. So B square plus C square upon 2 is greater than or equal to BC. C square plus A square upon 2 greater than or equal to C. Add the 3. So A square by 2, A square by 2 will become A square plus B square. B square by 2 and B square by 2 become B square plus C square is greater than or equal to AB plus BC plus C. Now AB plus BC plus C is a positive quantity. We can bring this into the denominator. So we get A square plus B square plus C square upon AB plus BC plus CA is greater than or equal to 1. So we divide by 2 on both sides. So we get the required lower limit of the required expression, that is twice of AB plus twice of BC plus twice of CA is greater than or equal to 1 by. So upper limit was less than 1, lower limit is half or greater than half. So the range what is asking, value range it can take is from 1 by 2. 1 by 2 is included, lower limit is included, but 1 is not included. So we say it's 1 by 2 close interval 1 open interval as answer. I hope this part is clear to everyone. I've shown you detailed solution. So when we add these three, A square by 2 and A square by 2 becomes A square, B square by 2 and B square by 2 becomes B square, and C square by 2 and C square by 2 when add becomes C square, greater than or equal to AB plus BC plus CA. So we bring to the denominator A square plus B square plus C square upon AB plus BC plus CA greater than or equal to 1. So we divide by 2 on both sides. So we get it's 1 by 2 comma 1 as the answer. Yes. Now, question number 12. If x, y, z are non-zero real numbers, find the minimum value of x. Before we start this type of question, whenever you take any positive number and its reciprocal, its arithmetic mean is a plus b by 2 and geometric mean is a into 1 by a to the whole power 1 by 2. This inequality is satisfied. Arithmetic mean of n numbers is nothing but x1 plus x2 up to xn divided by n. Geometric mean is x1, x2, product of these number to the whole power 1 by n. And harmonic mean is n upon 1 upon x1 plus 1 upon x2 up to 1 upon xn. Arithmetic mean is always greater than or equal to geometric mean, which in turn is greater than or equal to harmonic mean. We apply this to non-zero real numbers. One condition is non-zero real numbers, or we can say positive real numbers. And these three are equal when all the numbers are same. These three are equal when all the numbers are same. Otherwise, arithmetic mean is always greater than geometric mean, which in turn will always greater than harmonic mean. Now, whenever you take a positive number and its reciprocal, you take a positive number and its reciprocal. So, a positive number and its reciprocal, its arithmetic mean is a plus 1 by 2. They are positive. And the geometric mean is square root of their product. So we can find that a plus 1 by a upon 2 is greater than or equal to 1. So we'll remember this, any number plus its reciprocal, if it is a positive number, is either equal to 2 or greater than 2. Either equal to 2 or greater than 2. Take example, 1 plus 1 upon 1 is 2. 2 plus 1 upon 2 is 2.5. 3 plus 1 upon 3 is 3.33 and so on. If you take any positive number, you can take fractional also. Either the value is 2 if then both the numbers are 1, otherwise it's greater than. Now, let's simplify this expression. So what we derive from the previous slide is any number plus its reciprocal. If it is a positive real number, non-zero real number, its value is either 2 or greater than 2. You just simplify this part. It says x square y square plus x square z square upon y square z square upon y square z square. So first, from the first term we get two terms. One is x square upon z square, other is x square upon y square. Similarly, we can write the other terms also, but in this case we simplify these terms. So it's plus y square z square plus y square x square upon z square x square z square x square. So this which is outside, it remains in the numerator. It's y square upon x square plus y square upon z square. So if we understood the pattern, we can write the next term also. Let's simplify this. Z square x square plus z square y square upon x square y square upon x square y square. Z square was outside, it remains in the numerator in both the terms, and denominator we had x square cancel out. In this case it's y square, and in this case y square cancel out, it's x square. So we simplify one term and observe the pattern and write the remaining terms. Now we club the terms. If it is x square upon z square, last term is z square upon x square. You can say one term is x square upon z square, so last term is z square upon x square. We club these two terms. Then we had second term is x square upon y square, and we also had one term as y square upon x square. It's reciprocal. We club these two also. Then we had one term left as y square upon z square, and we had z square upon y square. One more term we have. So this is first term, it's reciprocal. Second term, it's reciprocal. Third term, it's reciprocal. And all these are non-zero. X, Y, Z were non-zero real numbers, so these all are positive real numbers. Now its minimum value is 2. Minimum value is 2 or more than 2. We are using this result. This is derived from AM is greater than equal to GM. Arithmetic mean is greater than equal to geometric mean. Its minimum value is also 2. Its minimum value is also. So we can say entire minimum value of the entire expression is, if we take minimum value of the three brackets together, that is 2 plus 2 plus 2, that is 6. So this entire expression is either 6 or greater than 6. We have to find the minimum value. Now minimum value of the entire expression is 6 as our answer. I hope this part is clear to everyone in the class. So ideally we haven't write so much when we are doing in the examination, because if we simplify the first term and observe the pattern, so we can simplify the other terms also in the similar manner. And we know if first term is x square upon z square, then its reciprocal is z square upon x square. If one term is x square upon y square, then its reciprocal is y square upon x square. If one term is y square upon z square, then its reciprocal is z square upon y square. So we had the three brackets, and each bracket has a minimum term equal to 2. So the entire expression got minimum when all the three brackets have got minimum value. That is 2 plus 2 plus 2. It gives us 6. Yes? Clear? Sure. Let's come to question number 13. It says we have to find the minimum value of this expression where x, y, z are positive. So let's try to simplify this expression. This is 2x upon 3z plus 2y upon 3z. Then we had 2y upon 3x plus 2z upon 3x. 2z upon 3y plus 2x upon 3y. Ideally, we had taken 2 by 3 common initially throughout. So first term becomes x by z, then y by z, then y by x, then z by x plus z upon y plus x upon y. Now 2 by 3 is outside. If we carefully observe, we had first term as x by z, so we had one term as z by x also. Just club them as they are reciprocal of each other. If we have one term as y by z, so we had one term as z by y also. X by z, y by z, and if we had one term as y by x, so we had last term as x upon y. Now, whatever this positive term z by x is its reciprocal, and we know minimum value of this bracket is 2. We are using the same identity again. A plus 1 by a is greater than or equal to 2. Only condition given is a is a positive real number. So minimum value of the first bracket is 2, second bracket is 2, third bracket minimum is 2. One number is, other is reciprocal. We have to find the minimum value of the entire expression. This is only possible when all the three brackets attains their minimum. This 2 plus 2 plus 2. So this comes out to be 6, and there is a 3 in the denominator. 6 by 3 is 2 into 2. So what is the minimum value of the entire expression is 4. This is minimum value of the entire expression. It's 2 by 3 of 2 plus 2 plus 2. That is 2 into 6 by 3. That is 2 into 2, which is 4. So we had minimum values. As we keep on increasing values of x, y, z, we are getting higher and higher values. We do not have a higher cap, but we had a lower cap. Lower limit is 4. It cannot go less than 4. Yes? Clear to everyone? Ideally, we could have taken 2 by 3 straight away in the first step. So we could directly come to this steps. And then if we observe that there is x by z and z by x, it's reciprocal. Y by z and z by y. Y by x and x by y. So three pairs are there for reciprocal. So we could straight away move forward. Question 14th. It says find the minimum value of the expression 7a square plus a plus 7 multiplied by 13b square plus b plus 13, 12c square plus c plus 12 divided by 27 abc, where abc are positive. So we had 1 by 27. We take a inside in the denominator of the first bracket, so that similar terms can be cancelled out. Then b in the second bracket, then c in the third bracket. It is 1 by 27. This is 7a plus 1 plus 7 by a. Then 13b plus 1 plus 13 by b. 12c plus 1 plus 12 by c. Just observe the steps. If you do this practice once or twice, then in the examination, straightforward answer. You can directly calculate the value. We know from which pattern, which part this theory is coming from. 1 by 27, we club the first and the second term. We take 7 as common. So it's a plus 1 by a plus 1. In this we club the first and the third part, take 13 as common. So b plus 1 by b plus 1. Then we take from the first and the third part of the bracket 12 as common, c plus 1 by c plus 1. I hope I am clear till now with everyone. We know one basic result: a positive number plus its reciprocal is either equal to 2 or greater than equal to 2. This applies to all the three cases. B plus 1 by b is greater than equal to 2 or greater than 2. C plus 1 by c is greater than equal to 2. They are all positive, non-zero real numbers. They are positive numbers. And we have to find the minimum value of the entire expression. So we say this minimum value will be only when all the three brackets attain its minimum. So minimum value is, in this case, is 7 into 2 plus 1, 13 into 2 plus 1, 12 into 2 plus 1. 7 into 2 is 14 plus 1 is 50. 13 into 2 is 26 plus 1 is 27. 12 into 2 is 24 plus 1 is 25. And we had 27 in the denominator. This 27 cancel out, so we got the minimum value as 15 into 25, which comes out to be 250 plus 125, 375. So we can say minimum value of the entire expression, minimum value of the given expression is 374. This is minimum value, or it is higher value. Now we are trying to find a logic from where does I am getting a minimum value. Sometime in the examination, such type of question can also be asked: which of the following can not be the possible value of this expression? Now three options are given: more than 375, and one option is given less than 375. So we will mark that option, that which is less than 375 is never possible, as entire minimum value of this expression is 375. I hope this is clear to everyone in the class. Yes? So this result, where do we get this result? Is arithmetic mean greater than equal to geometric mean. Now, question 15th. It says find the minimum value of this expression where x, y, z are non-zero real numbers. These are in multiplication. So we have to simplify them. Let's multiply the first two brackets. We are getting x square, y square plus x square, z square plus y square into y square is y4 plus y square into z square, and one more bracket we have z square plus x square, and the denominator we had x square, y square, z square. Let's multiply by these two brackets. First we multiply by z square, then by x square. So we get x square, y square, z square plus x square, z4 plus y4, z square plus y square, z4. We multiplied by z square all the four terms. Then multiplied by x square. It becomes x4, y square plus x4, z square plus x square, y4 plus x square, y square, z square whole upon x square, y square and z square. Now we had one x square, y square, z square and x square, y square, z square also. We can write twice of x square, y square, z square and keep x, divide by x square, y square, z square plus. Now bring this to denominator of every part. This is x square, z4. x square z4 upon x square y square z square plus y4 z square second term upon x square y square z square plus y square z4 upon x square y square z square plus x4 y square upon x square y square z square plus x4 z square upon x square y square z square plus x square y4 upon x square y square z square. We could have done division directly. I had just written to explain this concept more clearly. Now x square cancel out, z square cancel out. First term is 2. Then we had z square upon y square. Y square cancel out, we had 1 y square in the numerator, z square cancel out, y square upon x square. Y square cancel out, 1 z square left in the numerator upon x square. From this term, x square will there in the numerator, x4 upon x square, y square cancel out, x square upon z square. Then we had it's z square cancel out, x square upon y square plus it's y square upon x square cancel out, z square. Now we came to the same pattern what we had solved before. This is 2 plus z square upon y square, we had its reverse, last term y square upon z square. So we club this part together. Plus y square upon x square, we had x square upon y square also. Plus z square upon x square, we had z square upon x square, we had x square upon z square also. Now we know these are positive numbers and one number other is its reciprocal. Their minimum value is 2. We are again using the same inequality, that is a plus 1 by a is greater than or equal to 2. We derived from am greater than or equal to gm. So this bracket minimum value is 2, this bracket minimum value is 2, this bracket is minimum value is 2, and we have to find the minimum value of the entire expression. So we can say this entire expression minimum value is attained when all the three brackets attain its minimum value. So 2 plus 2 plus 2 is 6 and we had one more 2. So minimum value of the entire expression is 8. Is it 8 or greater than 8? So minimum we say minimum is 8. 8 as the answer. Yes? Clear to everyone in the class? Much of the steps can be saved. Now, we have to check the values. We have to know from where these values are come. What was the logic behind getting a minimum value? Now, question number 16th. It says if x square plus y square plus z square equal to 12, we have to find the minimum value of 1 upon x square plus 1 upon y square plus 1 upon z square. Now, one thing for sure is clear, that this x square, y square and z square are positive. So, we take this as arithmetic mean is greater than or equal to harmonic mean. Arithmetic mean of n numbers is x1 plus x2 up to xn divided by n, and harmonic mean is n upon 1 upon x1 plus 1 upon x2 up to 1 upon xn. We are assuming these numbers as non-zero real numbers, positive numbers. So square makes them by default positive. So it says for three numbers the same, x square plus y square plus z square upon 3 is greater than or equal to 3 upon 1 upon x square plus 1 upon y square plus 1 upon z square. Now x square plus y square plus z square value is given as 12. So 12 by 3 is greater than equal to 3 upon 1 upon x square plus 1 upon y square plus 1 upon z square. Now this entire bracket is positive. We can take this to the left hand side. 12 by 3 is 4, which comes in the denominator. So we got a simplified expression 1 upon x square plus 1 upon y square plus 1 upon z square is greater than equal to 3 by 4. So value of this expression is 3 by 4 or more than 3 by 4. We can say minimum value is 3 by 4. Yes? Clear everyone? Now, before moving forward, let's try to understand certain models. So first is model 1. It says if ax plus by is equal to k, where abxy, a comma b comma x comma y are all positive, and we have to maximize x to the power m into y to the power n, where m and n both are positive integers. So how do we find this value? It says if ax plus by is equal to k, an equation is given where a, b, x, y are all positive, and we have to maximize x to the power m, y to the power n, where m and n are positive integers. So what we do? We divide ax by power of x and by by power of y. Ax upon m is equal to by n, and then we use the property of ratios. It says ax plus by upon m plus n. So from here we got this value is given as k upon m plus n. What we have done, we have divided ax by power of x, ax upon m is equal to by upon power of y is equal to ax plus by upon m plus n, which is equal to k upon m plus n, because ax plus by value is given as k, a constant. So if we equate the first and the last part, we get the value of x. From this we can calculate the value of x by equating the first and the last part. And if we equate the second and the last part, we get the value of y. We can get the value of y also, x also. So substitute the values of x and y in this expression, you will get indirectly the maximum value. Now this is one way, what the model says, a shortcut. Let's take an example and try to learn this also. It says 5x plus 2y, 5x plus 2y is given as 50. I am taking an example to explain this model. 5x plus 2y is given as 50, and we have to find the maximum value of x cube y square. We have to find the maximum value of x cube y square. So what we do, 5x upon 3 divided by power of x is equal to 2y upon 2 is equal to 5x plus 2y upon 3 plus 2. We add the numerators, so we add the denominators. And 5x plus 2y is given as 50. 15 upon 5 comes out to be 3. So we equate the first and the last part. So we get 5x by 3 as 3. So we get the value of x as 3 square upon 5. and 2y upon 2 is 3. So we get the value of y as 3. Now just put this value in the expression. What we require to maximize, we have to maximize expression x cube y square. So x is 3 square upon 5 its whole cube, and y is 3, it's 3 square. So we get the maximum value as 3 into 2 6 plus 2, 3 to the power 8 upon 5 cube of the value expression what we require as the maximum. Now this is one way to understand this model. What we have done, we divide 5x by power of x and 2y by power of 2, and then we add the numerators, we add the denominator, and we get value as right hand side is 3. So we equate first and last part, get the value of x, second and last part, get the value of y, and put in the required expression which you have to maximize. This is one way to understand this. Let's solve this by one more method, one more way. Where does this come from? Why we are doing this part? It is given to us 5x plus 2y is equal to 15. And we have to maximize this expression x cube y square. Power of x is 3. So we divide 5x into 3 parts. 5x by 3, 5x by 3, and 5x by 3. And power of y is 2. So we divide this 2y into 2 parts. 2y by 2, 2y by 2. We know arithmetic mean of these 5 numbers is sum divided by 5, which is definitely greater than their geometric mean. Geometric mean says their product to the power 1 by 5. Square to the whole power 1 by 5. So we know arithmetic mean is greater than equal to geometric mean. Now 5x by 3 added thrice will become 5x, and 2y by 2 added twice will become 2y upon 5. This is greater than equal to, it's 5 to the power 3 upon 3 to the power 3 into x cube y square to the whole power 1 by 5. Now 5x plus 2y is given as 15, so we can say 15 upon 5. This is nothing but 15 upon 5, which is 3. 15 upon 5, which is 3. This is greater than equal to 5 cube upon 3 cube x cube y square to the whole power 1 by 5. Now we raise power 5 on both the sides, so it becomes 3 to the power 5. We raise power 5 on both the sides. To just simplify that 1 by 5th part, so it becomes 3 to the power 5 on the left hand side is greater than equal to 5 cube upon 3 cube into x cube y square. Now this positive we can take to the left hand side, so it becomes 3 to the power 5 into 3 cube upon 5 cube is less than equal to x cube y square. So x cube y square has maximum value as 3 to the power 8 upon 5 to the power 3. So what is the maximum value of this is 3 to the power 8, 5 to the power 3, and we have to go for less than equal to x. So we say maximum value of 3 to the power 8, 5 to the power 3 is x cube is this value or it is less than this. Clear? Yes? So we have to maximize this expression, so we get maximum value of this as either this value or less than this. So this is 3 to the power 8 upon 5 cube as the maximum value. So whenever sum is given and we have to maximize the product, indirectly what we are doing, we are making each term as equal. 5x by 3 as 2y by 2. Okay. So sum is given, product is maximum when all the terms are equal. Sure. So we get the maximum value of this as 3 to the power 8 upon 5 to the power 3. Clear? Now, model 2. Model second we have. It says if x to the power m into y to the power n is given as constant k, where x is greater than 0, y is greater than 0, and m comma n are positive integers, and we have to minimize, in this case we have to minimize ax plus by, where a is greater than 0 and b is greater than 0. So what we do in this case, we divide ax by power of x and by by power of y. Just equate these two. From here, calculate either x in terms of y or y in terms of x. X is equal to some value into y. That is, in this case it comes out to be bm upon an. It's bm upon an. And put this value in the given expression. X की power n, y की power n is equal to k. Substitute value of x here or substitute value of y here. You will get the values of x and y. Put them back into this value. You will get the required minimum value. Let's understood by taking this an example. I take an example. It says if x to the power 5 and y to the power 3 is given as 5 to the power 5 into 2 to the power 3. I have to find the minimum value of the expression 2x plus 3y. I need to minimize this minimum value. So what I do, I just divide 2x by power of x and 3y by power of y. So I simply get y is equal to 2x by 5. Just put this value of y in the given equation. It says x to the power 5 into y cube is equal to 5 to the power 5 into 2 cube. So I put the value of x, it becomes x to the power 5 into 2x by 5 whole cube is equal to 5 to the power 5 into 2 cube. This 2 cube will cancel out. So I got x to the power 5 into x cube upon 5 cube is equal to 5 to the power 5. So what I get, x to the power 8 is equal to 5 to the power 8, and since we have taken x greater than 0, so we take x equal to 5. Now when x equal to 5, I can simply find the value of y as 2x upon 5, that is 2 into 5 upon 5, value of y as 2. So minimum value of the expression is 2x plus 3y, that is 2 into 5 plus 3 into 2, that is 10 plus 6, which is 16. This is what I explain here. Divide ax by power of x and by power of n, by power of y, and get either x in terms of y or y in terms of x and substitute in the given equation. You will get in a single variable equation, solve that, get the positive values of x, then get the positive value of y and substitute back in the equation. This is one way to learn what is called as model 2. Now let's go further into this. Let's do it by a simple method also, or the logic we are using. These all models are given in your booklets. Read them from there. It says x to the power 5 into y cube is given as 5 to the power 5 into 2 cube. and we have to minimize the expression 2x plus 3y. This we have to minimize. Power of x is 5, so we divide 2x into 5 parts. 2x upon 5, 2x upon 5, 2x upon 5 plus 2x upon 5 plus 2x upon 5. Power of y is 3, we divide 3y into 3 parts. And we say arithmetic mean of this 8 number is this sum divided by 8 greater than equal to their product to the power 1 by 8. 2x upon 5 is 5 times, 3y upon 3 is 3 times to the whole power 1 by 8. So this is 2x by 5 added 5 times becomes 2x, 3y by 3 added 3 times becomes 3y upon 8 is greater than equal to 2 की power 5 upon 5 की power 5 into x5 y cube to the whole power 1 by 8. Now we wish to find the value of 2x plus 3y, minimum value greater than equal to 8. This inside bracket, when simplified, put the value of x to the power 5 y cube as 5 to the power 5 into 2 cube, which is given value 1 by 8. 5 to the power 5 cancel out, so we get 2x plus 3y upon 8 greater than equal to this 5 to the power 5 cancel out, 2 to the power 5 2 to the power 3 in multiplication, base are equal, we add the power, it's 1 by 8. We can say it's 2x plus 3y upon 8 is greater than equal to 2. So 2x plus 3y is greater than equal to 16. So minimum value of this expression is 16 or greater than 16. We are using this logic. This is also one way to solve. We should know why we are doing that particular shorter method. When sum is given, we wish to maximize the product. So this happens when all are equal. That's model 1. Model 2, when product is given as constant and we wish to minimize the sum of the quantities. Now this will again happen when all are equal. So this has to be carefully noted. Sure. Then model 3, model 3rd. It says the greatest value of a minus x to the whole power m into b plus x to the whole power m for any real values of x, or any real values numerically less than a and b, and also given mn belongs to positive integers, occurs when, this value occurs when a minus x upon m is equal to b plus x upon m. So from this, get the value of x and put them back into the expression to get the maximum value. Very simple. A minus x divided by m is equal to b plus x divided by m. Let's take an example. We have to find the maximum value, greatest value, that means maximum value. We have to find the maximum value. It says maximum value. The expression is 9 minus x whole square minus 4 plus x whole cube. We have to find the maximum value of this expression. M is equal to 2 in this case, n is equal to 3 in this case. 9 minus x minus 4 plus x. What we simply do is 9 minus x upon 2 is equal to minus 4 plus x upon 2. Just equate this, simplify this. 27 minus 3x is equal to minus 8 plus 2x. So we have 5x, 3x goes to the right hand side, minus 8 comes to the left hand side, it becomes 35. Get value of x as 7. Just put this value of 7 in the expression, we get this as 9 minus 7 whole square minus 4 plus 7 whole cube. 9 minus 7 is 2, 2 square is 4, and minus 4 plus 7 is 3, 3 cube is 27. So this is 4 into 27. 20 into 4 is 80, 7 into 4 is 28. So this comes out to be 108. Indirectly, this is the maximum value. So this model has to be learned in this manner. And straight away, whenever such a thing is being asked, we do 9 minus x whole square into minus 4 plus x to the whole 3. We have to find the maximum value. 9 minus x upon 2 is equal to minus 4 plus x upon 3. Just get the value of x and put back into the required expression. You will get the maximum value. Yes? Now coming to model 4. It says if a and b are two positive integers, these all models are given in your booklets. A and b are two positive integers, and we say the mean of their mth power, as m. Its mean of their mth power is m. That is, m is equal to a to the power m plus b to the power m by 2. This is m. And the mth power of their mean, other term is mth power of their mean, that is as p. P is equal to a plus b by 2 to the whole power m. P is mth power of their mean. We are taking for two positive integers right now. Mean of their mth power, that is m, a ki power m plus b ki power m by 2, and mth power of their mean as p. We assume this as p, a plus b by 2 ki whole power m. Now we had three cases. First, if this m is less than 0 or m is greater than 1, then we can simply say that p is less than or equal to m. P is less than or equal to m. That is, a plus b by 2 to the whole power m is less than equal to a to the power m plus b to the power m by 2. When m power is less than 0 or power is greater than 1, p is less than or equal to m. Yes? So p is less than equal to m. We can also take a simple example. We can say a plus b by 2 whole square is less than a square plus b square upon 2. Now this inequality holds when a is equal to, this inequality holds if a is equal to b. We have a is equal to b. Second point, If m is equal to 0 or m is equal to 1, then we can say p is equal to m. We can take this as simple. A plus b by 2 to the whole power 0 is equal to a to the power 0 plus b to the power 0 by 2. 1 is equal to 1 plus 1 upon 2. So 1 is equal to 1. That is when we take m is equal to 0, or we can say it's a plus b by 2 to the whole power 1 is equal to a to the power 1 plus b to the power 1 by 2. This is the second part here. And third part is as third part we have if m is greater than 0 but less than 1. In this case, m is less than equal to or equal to p. M is less than or equal to p. That is a ki power m plus b ki power m divided by 2 is less than or equal to a plus b by 2 ki whole power. So we had three cases. If m is between 0 and 1, the small m is between 0 and 1, that is power. We had capital M less than equal to p. It's a ki power m plus b ki power m by 2 is less than a plus b by 2 ki whole power. You have to learn these results. So whenever first case, if power lies less than 0 or greater than 1, we had p less than equal to m. That is a plus b by 2 ki whole power m is less than equal to a ki power m plus b ki power m by 2. If m is 0 or m is 1, p is equal to m. I had shown you by taking the values m0 or m1 in the case. And if m lies between 0 and 1, that is the other way around. M is less than equal to p. That is a ki power m plus b ki power m by 2 is less than equal to a plus b by 2 ki power m. And this inequality holds when a is equal to b. Now this rule can be extended for 3 or more quantities also. This rule can be extended for 3 or more quantities. You have to remember these models. For example, if it is says, you can extend this to 3 or more quantities also. A is greater than 0, B is greater than 0 and C is greater than 0. First case, if m is less than 0 or m is greater than 1. So we can simply say a plus b plus c by 3 to the whole power m is less than equal to a ki power m plus b ki power m plus c ki power m by 3. We can extend this rule further also for 4 or more quantities also. And this equality holds if a is equal to b is equal to c. Second case, if m is equal to 0 or m is equal to 1, we simply add p is equal to m, a plus b plus c by 3 to the whole power m is equal to a ki power m plus b ki power m plus c ki power m divided by 3. Third case, if m is greater than 0 but less than 1, it lies between 0 and 1, we had a to the power m plus b to the power m plus c to the power m divided by 3 is less than equal to a plus b plus c by 3 to the whole power. And this equality holds if a is equal to b is equal to c. Please remember these basic results. We had 3 cases and we can apply to 3 or more positive quantities also. I had shown you on 2 quantities, 2 positive or 3 positive quantities. Clear? Yes? Now it's model 5, that is model 5th. It says the minimum value of expression x plus a into x plus b upon x plus c. Minimum value x plus a, x plus b upon x plus c is occur when x is equal to under root of a minus c, b minus c, minus c is outside, and its minimum value is a minus c plus b minus c plus twice square root of a minus c, it's b minus c. It becomes easier if we find the value of x and put back into the expression. Let's take one example. It says we have to find the minimum value of 3 plus x, 6 plus x upon 2 plus x. This is the expression. We have to find the minimum value. So we know this occurs at x is equal to under root of a minus c, b minus c, minus c. So a in this case is 3 and b is 6, c is 2. C has to be less than both a and b. So it's 3 minus 2, 6 minus 2, minus 2. 3 minus 2 is 1, 6 minus 2 is 4, minus 2. This is 2 minus 2, which comes out to be 0. So minimum value occurs when x is 0. Just put value of x equal to 0 in the expression. It's 3 plus 0, 6 plus 0 upon 2 plus 0. That is minimum value comes out to be 9. Minimum value of the expression. So we can straight away do this part. We simply calculate the value of x at which it occurs and put the value of x in the expression. I hope this is clear. Let's take one more example on the same. We have to find if x is greater than 0. Condition is if x is greater than 0. We have to find the minimum value of 6 plus x into 18 plus x upon x plus 2. So we find the value of x at which minimum occurs. We have to find the minimum value. A is given, we have to find the minimum value. So it occurs when x is equal to under root of a minus c. Then we add it's a minus c, b minus c, minus c. So it is under root of 6 minus 2, 18 minus 2, then 2 outside, minus 2 outside. So 6 minus 2 is 4, 18 minus 2 is 16, minus 2. So we get 8 minus 2 as 6. Value of x as 6. Just put x equal to 6 in the given expression. It becomes 6 plus 6 into 18 plus 6 upon 6 plus 2. 6 plus 6 is 12. 18 plus 6 is 24. 6 plus 2 is 8. 8 into 3 is 24. And 12 into 3 is 36. So we get minimum value of the expression as 36. Straight away we can get the answers. So we should ideally remember these 5 models and apply whenever they are asked. So make sure that you clearly differentiate between which model is being asked. Yes? Yeah. Let's move further. Question number 17th. It says if 4x plus 5y is equal to 18 given, we have to find the maximum value of it's 4x plus 5y is equal to 18 given. So we do the first part. So what we simply learn in that model, we just divide 4x by power of x and 5y by power of y, and we add them. 4x plus 5y upon 4 plus 5 as 9. This is given as 18 upon 9, which is 2. Explain first two models just to cater these two questions. So if we equate first and the last part, we get the value of x as 2. Second and the last part, value of y as 2. We have to find the maximum value of x4, y5. Just put this into this expression. It becomes 2 to the power 4 into 2 to the power 5. So maximum value is 2 to the power 9. This is one way to do. Second way, what we have learned in that case, this is one straight away method. How do we derive this method is more important to learn. We divide 4x into 4 equal parts. 4x upon 4 plus 4x upon 4 plus 4x upon 4 plus 4x upon 4. And 5y into 5 equal parts. 5y by 5 plus 5y by 5 plus 5y by 5 plus 5y by 5 plus 5y by 5. Indirectly we are revising the model 1 again. These are 9 quantities, positive quantities. Their arithmetic mean is divided by 9, which is definitely greater than equal to their geometric mean, which is product of these numbers to the whole power 1 by 9. You can straight away get the result in a single line also. Now 4x by 4 added 4 times, it becomes 4x, and 5y by 5 added 5 times becomes 5y. So we had 4x plus 5y upon 9 is greater than equal to x to the power 4, y to the power 5 to the whole power 1 by 5. Now this value is 18. 18 upon 9 is 2. X to the power 4, y to the power 5 to the whole power 1 by 5. 1 by 9, it's 9. So it's 9. So we raise power 9 to both sides. It becomes 2 to the power 9 is less than equal to x to the power 4, y to the power 5 is less than equal to 2 to the power 9. So if somebody asks maximum value of this, so answer comes out to be 2 to the power 9. Otherwise value is less than this. Yes? Clear to everyone in the class? Let's do the second part. We have to maximize x to the power 5, y to the power 4. You can do directly. It's 4x divided by power of x is equal to 5y divided by power of y, and add the numerators. So you add the corresponding denominator also. So this becomes 4x plus 5y is given as 18 upon 9, which is 2. Just equate the first and the last part. So it's 2 and 4. X becomes, we get the value of x also, we get the value of y also. Value of x is 5 by 2 and value of y is, if you equate this, it comes out to be 8 upon 5. Put this value in the required expression, that is x to the power 5, y to the power 4. It's 5 by 2 to the whole power 5 we get, and y is 2 to the power 3 upon 5 to the whole power 4 we get. So this is 5 to the power 5 upon 2 to the power 5 into 2 to the power 3 into 4 becomes, we have to multiply this 12 upon 5 to the power 4. So we are left with 5 into 2 to the power 12 minus 5 is 7. 5 into 2 to the power 7. This is the maximum value what we got. This is one way to solve this. Sure. Explain you both the methods. Let's do it this by other method. This method I clearly explain you how do we get these values. Is 4x by power of x, 5y by power of y, then add them. You get a constant value. Get the values of x as well as y and put them back in the expression, you get the values. Now let's do it other way around. 4x divided by power of x, that is 5. We divide 4x into 5 equal parts. Five y we divide into power of y, 4 equal parts. How many quantities are these? 9 quantities. So their arithmetic mean is sum divided by 9 is greater than equal to their product 4x by 5 times 5y by 4 times whole to the power 1 by 9. Arithmetic mean is greater than equal to geometry. So 4x by 5 added 5 times becomes 4x and 5y by 4. 4x by 5, 4x by 5, 4x by 5, 4x by 5, 4x by 5 becomes 4x multiplied by 5. This multiplied by 4 becomes 5y upon 9 is greater than equal to 4 to the power 5 upon 5 to the power 5 into 5 to the power 4 upon 4 to the power 4 x to the power 5 y4 to the whole power 1 by 9. 4x plus 5y is 18 and 18 upon 9 is 2 on the left hand side. Right hand side we simply add 4 upon 5 into x to the power 5 y to the power 4 to the whole power 1 by 9. You could remember this method also. It's a basic straightforward method. Raise power 9 to both sides. So this becomes 2 to the power 9 less than equal to 4 is to the power 2 upon 5 x to the power 5 y to the power 4. So on simplification we get maximum value of x to the power 5 and y to the power 4 as less than equal to 2 to the power 7 into 5. This is the maximum value we are getting or less than this. So we can directly get 2 to the power 7 is 128 into 5. This comes out to be 640. Yes? Sure. So let's move further. This was model 1. Question 18 is actually model 2 we have. It says if x and y are positive integers satisfying x to the power 4 into y is equal to 32. Product is given and we have to find the minimum value of this. Product is given, we have to find the minimum value of this. So we simply say, let's do by the shorter method first. We divide x by power of x and y term, that is 8y, by power of y, and express either x in terms of y or y in terms of x. We take y as x upon 32. Just put this value of y in this equation. We get x4 into y as x upon 32 is 32. So x to the power 5 is 32 into 32. 32 is 2 to the power 5. So it becomes 2 to the power 5 into 2 to the power 5. We have to take positive numbers. So we simply say x to the power 5 is 2 to the power 10. So x comes out to be 2 square, that is 4. We get the value of x as 4. Put this value of x in this equation. We get y as 4 upon 32 as 1 by 8. So we get the value of x, we get the value of y, and we have to find the minimum value of x plus 8y. x is 4 plus, we got x plus 4y, 8 into 1 by 8. So this 8 and 8 cancel out. So minimum value of x plus 8y comes at 4 plus 1, that is 5. This is one way to solve this. Why did I explain the models? Just to address these two questions carefully. 4 plus 1 is 5. I hope this approach is clear. We divide x by term containing x by power of x and y 8y by powers of y. So x upon 4 is equal to 8y upon 1. We get y is equal to x upon 32. Put this value into the given equation. We get the value of x. And whatever x you get, put back to get the value of y. Just substitute. You get the minimum value. One important result, whenever product is given, he is asking sum to be minimum. Sum is given, he will asking you product to be maximum. Indirectly, both of these happens when all the terms are. Let's do it by the basic method once again. We divide term x by power of x, that is divided into 4 equal parts. X by 4 plus x by 4 plus x by 4 plus x by 4. And 8y by power of y, a single term. We had these 5 terms whose arithmetic mean is greater than equal to their geometric mean. X by 4 is 4 times and 8y is 1 time. To the whole power 1 by 5. There are 5 terms. So we had x plus 8y upon 5 whose value we wish to find. And in this bracket we had 8 in the numerator and 4 to the power 4 in the denominator, and we had x to the power 4 y to the whole power 1 by 5. Just substitute the value of the equation which we know, x plus 8y we wish to find. This is equal to 8 upon, this is 4 into 4 into 4 into 4, and we had x square into y as 32 to the whole power 1 by 5. So it's 16 to 16. We get this value as 1 inside the bracket. 8 into 2. 4 into 4 16. 8 by 16 is 1 by 2. And 16 into 2 is 32. 32 by 32 is 1. So we simply say x plus 8y upon 5 is greater than equal to 1. We can say x plus 8y is greater than equal to 5. So what is the minimum value of x plus 8y? Minimum value of x plus 8y is 5. Sure. Minimum value of x plus 8y is 5. Everybody understood this part? Now just for your basic understanding what I said. In the previous case, same case we got x as 4 and y as 1 by 8. Just see this, 4 by 4 is 1 and 8 into 1 by 8 is 1. Indirectly we had made all the terms equal. This is what I wish to explain. Whenever sum is given, product is, he will ask you to maximize the product. It happens when all the terms are equal. And if product is given and if it is to minimize the sum, it happens when all the terms are given. If we put x equal to 4, 4 by 4 is 1. All these 4 terms are 1. And y was 1 by 8. 8 into 1 by 8 is again 1. Yes? I hope these models are clearly understood by all. Yes? Now, question number 19. It says, which is greater? This we have to find. 60 to the power 61 or 61 to the power 60. Now let's assume A is 60 to the power 61 and B is 61 to the power 60. An assumption we are taking. Now we are finding a fraction B by A. That is 61 to the power 60 upon 60 to the power 61. This we can simplify as 1 upon 60, 61 to the power 60 upon 60 to the power 60. We had kept 1 aside in multiplication. So we can write B by A as 1 by 60. It's 61 upon 60 to the whole power 60. Yes, this is 1 upon 60. 1 plus 1 by 60 to the whole power 60. This is b by e. Now please remember a result. 1 plus 1 by x to the whole power x is greater than equal to 2 and less than 2.72. We are talking about x as a positive. It's 1 plus 1 by x to the whole power x is greater than equal to 2 and less than 2.72. So we know maximum value what this bracket can assume is between 2 to 2.72. So when divided by 60, we can simply say this b by a is less than 1. Because its value 1 plus 1 by x to the whole power x is greater than 2, less than 2.7. So we are using the result for all positive values of x. Its values lies between 2 and 2.7. So if this value is 2 or any value from 2.72 divided by 60, this value is less than 1. That means b by a is less than 1. That says a is greater than b. A is greater than b. That means 60 to power 61 is greater than 61 to power 60. This is in which manner we solve these type of questions. So 1 plus 1 by x to the whole power x for positive values of x, this always lies from 2 to 2.7. First term is 1, the second term is 1 upon 60 should be less than 1. The positive values of x we are talking about. This should be less than 1. We get this value as 2 to 2.72. Whenever expression is in this form, we can gauge the range of 1 plus 1 by x to the whole power x. For all positive values of x, we are taking when this is 1 by x. Yes? Here. So we use this identity, this result to get our value. Now 20th. It says x lies between minus 4 to 9. X varies from minus 4 to 9. And y take values from minus 6 to 8. We have to find the range of xy, that is minimum value as well as maximum value. Now to obtain a minimum value, what we do, we can put the value, we can maximize one value and introduce a minus sign from the other value. This can be done. For example, maximum value is 8, in this case is 9. If we take x as 9 and y as minus 6, so this becomes minus 54. We introduce a negative sign. And if we want to maximize the value, we multiply both positive values. 9 into 8, that comes out to be 72. So this is the minimum value and this is the maximum value. Let's do more iteration. Suppose we take minimum, instead of minus 6 we have taken minus 4 as value of x. Then y we can take as positive value, because positive into negative will make negative. This becomes minus 32. Now minus 54 is less than minus 32. So minimum is minus 54. For maximum there is no doubt. We multiply this 8 into 9, or we can multiply both negative values also, because negative into negative becomes positive. Minus 4 into minus 6 becomes plus 24. But in this case we had 72. So this is the maximum value, this is the minimum value. I hope this is clear. You just find the range and get the values. Clear to everyone in the class? Yes? Now, coming to additional questions for practice, question 1. It says we have to solve this. We have to solve this part. First of all, we have to factorize this expression, numerator as well as denominator. So it's 28x square. So we can take 7 and 4 as the factors. We can write this numerator as x square minus 7x minus 4x plus 28. And in the denominator, 5 into 6 is minus 30. So we require two factors. Sum is positive but product is negative. So 15 and minus 2. We write 5x square plus 15x minus 2x minus 6. This has to be greater than 0. So we simplify the numerator part. We take x as common. It's x minus 7 minus 4 is common. X minus 7. Denominator we take 5x as common. It becomes x plus 3 minus 2 as common. X plus 3. This is greater than 0. So x minus 7 into x minus 4 upon 5x minus 2 into x plus 3 greater than 0. Now, most important point, this is not defined at x is equal to 2 by 5 or x equal to minus 3. Both these values are straight away rejected. Otherwise, the denominator becomes 0. So, x cannot be equal to 2 by 5, x cannot be equal to minus 3. Now, we multiply by 5x minus 2 in the numerator and denominator and x plus 3 in the numerator and denominator. So, this becomes x minus 7 into x minus 4 into 5x minus 2 into x plus 3. Denominator it becomes 5x minus 2 into x plus 3, both square, greater than 0. And we straight away say x cannot be equal to 2 by 5, x cannot be equal to minus 3. So these two are positive quantities. So we take this values to the right hand side, they got 0 term. So we arrange this bracket in ascending order. It becomes x plus 3, then 5x minus 2, then x minus 4 into x minus 7 is greater than 0. We take 5 common from this part and make it take to the right hand side. It becomes x plus 3, x minus 2 by 5, x minus 4, x minus 7 is greater than 0. Now take a number line. Plot them in ascending order. It's minus 3, it's 2 by 5, it's 4, and then 7. And we know right hand side is always positive. Why it is always positive? Take any number greater than 7. Suppose we are taking 10. 10 plus 3, 13, positive. 10 minus 2 by 5 is positive. 10 minus 4 is positive. 10 minus 7 is positive. All values are positive. Then it moves alternatively. Then negative, then positive, then negative, then positive. Now we know the initial constraint x cannot be equal to 2 by 5, x cannot be equal to minus 3. Now we required greater than 0. We required greater than 0, that is positive. So x is greater than 7 or x lies between 4 and 2 by 5 or x is less than minus 3. So if we write in terms of bracket, we can write it minus infinite to minus 3, open interval, both are excluded, middle terms are taken, union 2 by 5 to 4, again open interval because it's not equal to here also. And we cannot take 2 by 5 as and minus 3 as the values. Union, it's 7 to infinite, again in open interval. So this is solution for this one. I hope this is clear. These values are positive, so we merge them with 0. So they are not going to change the sign of the inequality. And then we plot a number line, plot all the points in ascending order, and then right hand side is always positive. We move positive, negative, positive, negative, positive. And then if we require greater than 0, we pick the positive ones. If we require less than 0, we got to pick the negative ones. Yes, clear to everybody in the class? Sure. No. Question number 2. It says if ABC are positive numbers which are in arithmetic progression. 3 numbers are in arithmetic progression, that means their difference is constant, and their product is given as 64. We have to find the minimum value of B. So if ABC are the number in arithmetic progression, we can say their difference is constant. That is, we can say A plus C is equal to 2B. A basic property for 3 numbers to be in arithmetic progression. Now they are positive numbers, we can say arithmetic mean of A, B, C is definitely greater than geometric mean of A, B, C. That is, A plus B plus C upon 3 is greater than equal to ABC to the whole power 1 by 3. We have to find the minimum value of B. We know A plus C is equal to 2B. So just put the value of A plus C, that is 2B plus B upon 3 is greater than equal to 64 to the whole power 1 by 3. So it's 3B upon 3, that is B is greater than equal to 64 is 64, we will find cube root, it's 4 cube, we get 4. So what is the minimum value of B? We get as 4 as the minimum value. So we use a property of arithmetic mean, their differences are constant, and we use AM greater than equal to geometric mean JM. So we use that property. Clear? Question 3. It says solve mod 5x minus mod 8x plus 9 equal to 24. So we take case 1. When we take 8x plus 9 is greater than equal to 0, or indirectly we are taking x greater than equal to minus 9 by 8. So this is positive, so mod will do nothing, it will leave a plus sign outside the bracket, so this becomes mod of 5x minus of 8x plus 9 modulus is equal to 24. We had assumed x greater than equal to minus 9 by 8. So 5x minus of 8x is minus 3x minus 9. It's inside modulus. So we can say it's minus 3x minus 9 is equal to 24. We can write this as 3x plus 9. Mod of 3x plus 9 is equal to 24. So whenever we remove the modulus sign, a plus and minus both will appear. So we take two parts. We say 3x plus 9 is equal to 24, or 3x plus 9 is equal to minus 24. We can do this part here also. It's minus 3x minus 9 equal to plus minus 24. Doesn't make a difference. But logically when it's inside mod, we're getting a positive value. So 3x plus 9 modulus is 24. We remove this modulus sign, we take two sign, plus as well as minus. So this gives us 3x is equal to 24 minus 9, which is 15. So we get x equal to 5. Now this value is greater than 9 by 8. So we select this value. X equal to 5 is accepted. Now 3x is equal to 24. Minus 24 and minus 9 is minus 33. So x equal to minus 11. This is not greater than minus 9 by 8. So we reject this value. So we got one value as x equal to 5 in this range. First case. Case second we take, what is case second we have? We take 8x plus 9 as less than 0. So mod put out, that is x is less than minus 9 by 8. So instead of 8x plus 9 modulus, we should have write minus of 8x plus 9, because we are considering values which are less than minus 9 by 8. So our basic question which is given in this form, this becomes 5x minus of minus is equal to 24. So 5x plus 8x plus 9 modulus is equal to 24. 8 plus 5 is 13x plus 9 modulus is equal to 24. So when we remove modulus, we have to consider two cases, both plus as well as minus. So we take 13x plus 9 is equal to 24, or 13x plus 9 is equal to minus 20. So first part gives us 13x is equal to 15, x is equal to 15 by 13. Now this 15 by 13 is not less than minus 9 by 8, so we reject this one. Then we add 13x plus 9 is equal to minus 24. So 13x is equal to minus 24 minus 9 is minus 33. X is equal to minus 33 by 13. Now this value is less than minus 9 by 8. So we select this value. So in all, how many values of x we got? We got two values of x. One is x is equal to 5, and second, or x is equal to minus 33 by 13. These two are the values which we got for as an answer for x. So we solve this equation and we get two values of x. X is 5 or x is minus 33 by 13. Yes? I hope this part clear to everyone. Clear? Now it says mod 3x minus 8 is less than equal to 23 and mod 5y minus 14 is less than equal to 29. We have to find the maximum value of mod x minus mod y. So if we wish to maximize this mod x minus mod y, we try to minimize mod y and we try to maximize mod x. So whenever it's given mod of x minus a is less than equal to b, so we can say x minus a is less than equal to b or greater than equal to minus b. Let's solve this. 3x minus 8 is less than equal to 23, greater than equal to minus 23. So we add 8 on all the side, we get 3x less than equal to 31, greater than equal to minus 50. We divide by 3, x is greater than equal to minus 5, less than equal to 31 by 3. Yes? Now simplify the second part. Second part says mod of 5y minus 14 is less than equal to 29. That is 5y minus 14 less than equal to 29, greater than equal to minus 20. So we add 14 to both sides, it becomes less than equal to, we add this for 43 and greater than equal to minus, we add 14 to this, minus 50. So we get divide by 5, y is less than equal to 43 by 5 and greater than equal to minus 3. So we get values from y values range from minus 3 to 43 by 5 and x value range from minus 5 to 31 by 3. Now 31 by 3 is 10.33. We have to maximize this expression mod x minus mod y. Now if we take any value of y as negative also, then it will give a positive value. Mod will give a positive value. So we take this part y as 0. At 0 lies in this range. And we take biggest value of x, 31 by 3 possible. And we subtract these two. So we get maximum value of the expression is mod x minus mod y as 31 by 3 as the answer. So indirectly we maximize mod x, we minimize y. So that mod y got minimum. We put 0 in that case. Clear? Yes? Question 5. It says how many integral values of x satisfies this? How many integral values of x satisfy this? Let's first try to draw the graph of mod x minus 8 plus mod x minus 3 plus mod x plus 3 plus mod x plus 8. Then see how many values of x we get. Value this as 14. So we write this as fx is equal to mod x plus 8 plus mod x plus 3 plus mod x minus 3 plus mod x minus 8. Now, we divide the number line into minus 8, minus 3, 3 and 8. So in all we have 5 intervals. When x is less than minus 8, all the mods are negative. Let's try to solve this. When x is less than minus 8, all the 4 mods are negative. We are just drawing the graph of this left hand side. So we got all the 4 as negative. When x is greater than equal to minus 8 but less than minus 3, first become positive, remaining 3 are negative. But when minus 3 to 3, we add first 2 positive and the next negative. 3 or more and less than 8, first 3 mod positive, next negative, and greater than equal to 8, all the mod positive. Let's try to figure out the equations in the respective regions. So either we can directly take the first case when x is less than minus 8. So y is equal to, it becomes minus x minus 8 minus x minus 3. It's minus x minus 3, then minus x plus 3 minus x plus 8. So we get y is equal to minus 4x. Yes. In the second interval, when x is greater than equal to 8, minus 8 and less than minus 3. First mod is positive, whereas other are negative. X plus 8 minus x minus 3 minus x plus 3 minus x plus 8. Y comes out to be minus 2x plus x minus x cancel out, minus 2x plus 16. Third, when x is greater than equal to minus 3 and less than 3. So first 2 mod are positive, last 2 are negative. So y is x minus 8, sorry, y is x plus 8 and x plus 3, first 2 are positive, minus x plus 3 minus x plus 8. So this plus 2x and minus 2x cancel out. We get a constant value 8 plus 8 16, 3 plus 3 6, y is equal to 22. We know this is horizontal line parallel to x-axis. When x is between greater than or equal to 3 and less than 8, first three mods are positive, last is negative. So we get y is equal to x plus 8, x plus 3, x minus 3, and then we add minus x plus 8. So minus 3 plus 3 cancel out, 1 x and minus x cancel out. We got x as y is equal to 2x, and then we got this as plus 16. 16. And when x is greater than or equal to 8, we had all the mod as positive. So y is equal to x plus 8 plus x plus 3 plus x minus 3 plus x minus 8. So simply get y is equal to 4x. Now we have to draw the graph of this. Y is equal to 4x. I hope this part is clear. First interval it's minus 4x, y is equal to, then y equal to minus 2x plus 16. Then third it's y equal to 22. Then 2x plus 16. And then fifth interval y equal to 4x. So let's draw this graph. This is minus 3. Then we add minus, first is minus 8. Then we add minus 3. Then we add 3. Then we add 8. So in this case, this is y is equal to minus 4x. Case 1. Case 2, we had y is equal to minus 2x plus 16. Third case, y is equal to 22. Fourth case, 2x plus 16. And fifth case, y is equal to 4x. So we should draw the graph in the respective regions. It will come like this. Here it becomes horizontal. Then it's ascend forward, then it moves. We know value changes at the endpoints. This is 22, that is minimum value. It's minus 3 comma 22. It's 3 comma 22. This is minus 8, 32. This is 8, 32. And values increase. So how many, if the question would have been how many values of x satisfies this equal to 22, so all the values from minus 3 to 3, all real numbers, both included, because in this part it becomes independent of x. But it says how many integral values. So we have to give integral values. So how many integral values of x satisfy this? It's minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. So how many integral values we have? 7 integers. We have 7 integers. So it's 7 integral values of x, and these are the 7 integral values which satisfies this. Yes, we know the value changes at 22. Value changes at this endpoint, and he is asking value 22, and we know this is the minimum value. Had there been 20, then no value of x will give 20 as the answer. But about 22, this is the minimum value, which is somewhere in the central interval, minus 3 to. Yes, I hope this is clear to everyone. Thank you. Thanks.